Okay, I would like to introduce to you about the Pelton impulse turbine. So in the turbine types, we have two types of turbine. We have impulse turbine and reaction turbine. So this is one example of impulse turbine, Pelton turbine. Okay, for the reaction turbine, actually we have Francis turbine, we have turbo turbine, and also we have propeller type turbine. Okay, so this is the Pelton turbine that we can use actually to measure the power generate. The frequency we use normally is 50 hertz. Okay, so the difference between the reaction and the impulse turbine, actually for the impulse turbine, we need to use the flow energy from the water. We have to convert to the kinetic energy. So after we convert to the kinetic energy, so the water jet that come out from the nozzle will impact to the bucket here. So the bucket will rotate. For the reaction turbine, we use the flow energy of the water to rotate the runner. Okay, so this is the difference between the Pelton, the impulse, and the reaction turbine. Okay, so to detail explanation about this experiment, I would like to introduce Mr. Nosham, our technical assistant here. So please welcome to Cik Nosham. So here is the Pelton equipment here. This is a Pelton equipment for motor. This is a motor. This is a pressure, flow rate, torque, and speed. And this is for the turbine. Force 1, force 2, force 1, pressure and speed. This is a force 2 and force 1. Okay, here we start our experiment here. So we increase the pressure here. So maximum 1,500. So this is actually the bypass valve. So actually before we start the experiment, we need to fully open the bypass valve. Okay, because after we run the pump, we don't want the high pressure to impact to the system. So bypass valve is used to channel the high pressure pump go back to the tank. Okay, this is the control valve. So see the maximum. 1,700 pressure, okay, motor 2,750, loaded. Something wrong with over here. 53. Okay, this is our speed 2,790. Okay, the high speed of the water jet, okay, will impact into the bucket. So this back side of the bucket, actually we put the wheel here. So you put the wheel. So this wheel will calculate the force. We have a force number 1 and force number 2 here. So currently there is no load on the belt. Okay, if we put the load, now this control, we put the load. So as you can see here, the force number 2, okay, become 0.19, and then force number 1 will increase to 0.27, 2.4. Okay, from this force actually we can calculate the torque, and then from the torque we calculate the work. After that we can calculate the power and then the efficiency. Okay. Okay, we can open this software. Actually, this software is will calculate everything. We can calculate force, torque, work, power, and the efficiency.
We capture 1,300. Then we can take the tables. Here is load 1, load 2, pressure, flow rate, and speed. Here we can check the table here. This is for 1,600. Okay.
Okay, so we increase the load. After we increase the load, and then we capture. So we get the value here. As we can see here, the flow rate is 53, and then the output power 2.2.7, and then the last one is the efficiency here. Okay, 14.1183. So this experiment actually we tighten the bed, and then we try to decrease the RPM 100, okay, until 700. So for each 100 we decrease the RPM, and then we capture inside the software, and then we can get the value. Okay, actually the performance, the speed will increase, and then normally until 700 or 600, and then the slope will going down, the graph will going down. So we know the optimum position. The optimum position is the top one. So and then we can measure the speed here. So the speed here we will know at this location. Actually, the pump works at the maximum efficiency. Okay, that's all. Thank you very much.